The term patch is common in analog synthesis technology, and a patch is a nickname for the specific sound that's being created by the synthesizer at any given time. So a patch is a way of referring to a specific sound, whether or not it's a trumpet or a drum or a clarinet. But why do we call it a patch? Well, take a look at the Moog modular synthesizer, and it has a number of modules on the rack, and you use patch cords to interconnect the modules. So for example, maybe this cord is joining an oscillator to a mixer. Maybe this one is joining an envelope generator to a voltage controlled amplifier, and what have you. So the artists will interconnect all these various modules together using patch cords, as they're called, and altogether you say the specific connection is called a patch. Here's another example, the Buchla electric music box from around 1963 approximately. Again, you just see it's lots of cords interconnecting all the modules together. Well, let's consider a basic patch example for producing a sound similar to a physical instrument. This circle shape indicates a signal source. VCO is an acronym for voltage controlled oscillator, and the little symbol on the inside of the circle tells you whether or not it's a sine wave or a square wave or a triangle wave or other types of wave shapes. Next, I'll pass this through an amplifier, denoted by the triangle symbol. This is called a voltage-controlled amplifier, where the gain of the amplifier is controlled by a voltage. And a control voltage generally is abbreviated as CV. Next, I'll draw a rectangle symbol to denote an envelope generator. And the purpose of the envelope generator is to produce a control voltage that can be used by the voltage-controlled amplifier. So we see that the amplitude would start low, it ramps up to a peak value, and then it starts to decay again. And typically the envelope is created using exponential curves. So with just these three elements, we produce an output that has basically a sinusoidal characteristic, but it's being shaped in terms of its amplitude by that exponential rise and then the exponential decay. So if we were to listen to this, it might sound something like, say, a short tap on a bell or some other kind of mallet instrument where we hit it, so we get a strong amplitude at the beginning, and then it kind of fades away. Now, typically these modular synthesizers are controlled from a keyboard, and the keyboard is responsible for establishing the frequency of our voltage-controlled oscillator. So the keyboard also produces a control voltage. And in this case, the VCO interprets that control voltage to indicate frequency. And commonly, you might use a standard like 1 octave per volt, or something similar to that. Now the keyboard control voltage tends to be rather discrete. So as you're playing the different keys, it will emit a constant control voltage for a given period of time. You press a different key and you get some other control voltage. So it tends to look like the sort of the step type pattern that I'm indicating. The other voltage coming out of the keyboard is called the gate. And this gate signal is on whenever any one of the keys is pressed. And it's simply more of a digital type signal. It's either on or off. The envelope generator then can interpret this gate signal to say if a key has just been pressed, say when the gate goes active, that can be used as a trigger point to start the envelope generator producing its control voltage for the VCA. So again, that leading edge of the gate will oftentimes serve as the trigger for the envelope generator.